Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the normal distribution. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. This PowerPoint is based on a standard z-table that gives the area to the left, and students must have access to that type of standard normal table. We will cover three topics in this PowerPoint: the number of standard deviations from the mean, or the z-values, the empirical rule for normally distributed data, and word problems with normally distributed data. Topic number 1, the number of standard deviations from the mean, or the z-values. X is normally distributed with a mean of 60 and a standard deviation of 5. Mean, or mu, is 60. Sigma, or the standard deviation, is 5. Draw a bell-shaped or normal curve. Then we will label underneath it our x values. Mu equals 60, or the mean is 60, will then be placed in the center. Using our standard deviation of 5, or sigma equals 5, we will use that to jump 5 for our first tick mark and give us 65. 60 plus 5 equals 65. Plus 5 more equals 70. Plus 5 more equals 75 for 3 standard deviation jumps to the right. To jump to the left, we will subtract 5 as we are going down the number scale. 60 minus 5 gives us 55. 55 minus 5 gives us 50. And 50 minus 5 leaves 45. We now have our x value number line labeled. Every x value has a corresponding z value. The z value tells us the number of standard deviation jumps from the mean. One jump indicates that 65 has a corresponding z-score of a positive 1. Z equals positive 1. One standard deviation jump from the mean corresponds to the x value of 65. One jump, two jump lands us at 70. Z equals 2 indicates that we have made 2 positive standard deviation jumps from the mean. 1, 2, 3. 3 standard deviation jumps from the mean lands us at 75, which corresponds then to z equals 3. Positive 3 standard deviation jumps from the mean. 60 corresponds to z equals 0 for 0 standard deviation jumps from the mean. A minus 5 means that we have decreased or jumped to the left 1 standard deviation, which would then correspond to z equaling a negative 1, or a negative 1 standard deviation jump from the mean. 1, 2 jumps to the left lands us at 50, which corresponds to z equaling negative 2, negative 2 standard deviation jumps from the mean. 1, 2, 3, negative 3 standard deviation jumps lands us at 45, which corresponds to z equaling negative 3, negative 3 standard deviation jumps from the mean. The z-value is the number of standard deviation jumps from the mean. So now we have an x-value scale and a z-value number scale or number line. Notice that that gives us the two number lines, one with x values, one for the z values. Each x value has a corresponding z value. Each x value has a corresponding z value. Z equals x minus the mean over the standard deviation, or x minus mu over sigma. You can use this formula to find the number of standard deviation jumps from the mean. If z is positive, then the data value is to the right of the mean. If z is negative, then the data value is to the left of the mean. Notice 70. It corresponds to 2 standard deviations above the mean. Use the formula for z to show that if x equals 70, then z equals 2. Our formula, z equals x minus mu divided by sigma, or x minus the mean divided by the standard deviation. 70 for your x, minus 60 for the mean, divided by 5 for our standard deviation. 70 minus 60 is 10. 10 divided by 5 leaves me 2, and we've proved that if x equals 70, then z equals 2. Use the formula for z to show that if x equals 45, then z equals negative 3. Z equals x minus the mean over the standard deviation. X is 45, the mean is 60, the standard deviation is 5. 45 minus 60 divided by 5. 45 minus 60 is negative 15. Negative 15 divided by 5 leaves us negative 3. Be sure that you're following the order of operations and doing the top of your fraction and then the division. If x equals 68, find the z value. Notice 68 falls in between and therefore will not be a whole number. It falls in between two whole number z values, therefore it will not be a whole number. Z equals x minus the mean divided by the standard deviation. 68 minus 60 divided by 5, which leaves us 8 divided by 5, or 1.60. Notice how that does fall appropriately between 1 and 2 and gives us the answer. Here is a student activity for you to try and a couple of problems. And we will pick up with topic number 2 in part 2 of this series. Thank you.